Okay, so up to now, let me switch over here to the textbook here. So this is a nice summary of what we've done so far, right, in terms of what we have been counting. So if we see this table here, the top row, we have distinguished arrangements, and that just means, for example, like if we had like 1, 2, 3, right, as a string or a sequence that you distinguish it from 3 to 1 per se, right? Or do we want to distinguish between those, right? Yes or no, and then whether we have repeats or no repeats, right? And we see so far if we do have distinguished arrangements and we allow for repeats, then that's the product principle. No repeats is the sequence of permutations, and if we don't care about whether the arrangement is unique or not, right? So 1, 2, 3 is equivalent to 3, 2, 1. Then that's a combination, right? And we use the choose number. Now, what we have not discussed yet, and we'll start discussing now, is, well, what if I allow the distinguisher repeats? Well, excuse me. What if I allow repeats and I don't distinguish between the arrangements either? All right. So let me illustrate kind of what that means. All right. So for example, let's say we have, here's a picture of some jelly beans, right? So we notice here there's several colors, and several of those colors show up in different amounts, right? So let's say you were to grab a handful of them. Let's say you wanted to grab like 10 of them, right? And how many different handfuls of 10 jelly beans do you have? If there are, for example, here we have roughly like 6 colors, right? And however many candies there are. So that is a type of problem that we want to answer, all right? Because now I can allow for repeats, right? And the order is not distinguished, right? So it's unordered in the sense that like blue, yellow, same as yellow, blue, right? And I can have repeats. I can have 4 yellows to 3 blues, etc. Right? So now that's much different than what we've done so far, right? So what that entails is this idea of counting a multiset, right? So first, let's kind of introduce here our new vocab here. So we're going to be looking at what is called a multiset. So a multiset is simply an unordered collection where elements repeat. All right, so if you look at our jelly beans here, so where we can have, like, let's say blue for picking, let's say we just grab a handful of, let's say 6. We got blue, blue, yellow, red, yellow, some other color in there, green, green. Right? And just rearranging them, right, would also be valid here, but we are allowing for repeats, right? So the idea is, how can I determine, right, how many of these multi-sets I have, or how many ways can I grab a handful of these jelly beans, right? So the process that we're going to use is what's referred to as kind of sticks and stones. Okay. All right. So let's take a look at this example here, and I want to distribute seven cookies to 4 kids. All right, now the cookies, they're identical. All right, so they are all the same. Okay, so I don't distinguish the arrangements of those. And I can distribute how I want to determine how many ways can I do that to 4 kids. All right, so one way to think of this is this method called sticks and stones, where you assign one quantity a stone and then one a stick. All right, so here we're gonna let the cookies be the stones, right? So 1, 2, 3, 4, 5, 6, 7. All right, and what I want to do here is I'm going to use, so here the stones represent the cookies, and then the sticks are going to represent the kids. All right, now, and what I mean by that is, well, let's say that I do this, right? So here, what we have here, as I said, right, the first kid, so kid 1, right, gets 2 cookies. Right, so that stick kind of separates, right, how many cookies one of these kids gets, right? And then kid 2 also gets 2 cookies. Kid 3 also gets 2 cookies. And then kid 4 he gets 1 cookie. Right. So now notice here that in this kind of way that I formulate, I don't need 4 sticks, right? Because that last one, whatever's left over, I don't need another stick to kind of cut it off here. All right, so to represent the 4 kids, I just need 1 less stick, right? Since I don't need a stick kind of out here. Okay, now if we think of the problem like this, right, we think, well, every outcome has 7 stones, the cookies, and 3 sticks. Right? So whatever the amount of kids, minus 1. Right? For a total, really, you can think of these as 10 symbols, really. Right? And it really comes down to us, how can I arrange these 10 symbols? Right? I can do this, right? I can do that as well. All right, and in this formulation, kid 1 gets 1 cookie, kid 2 gets 1 cookie, kid 3 also gets 1 cookie, and the 4th kid gets 4 cookies. All right, so we can see now it's more of a combination problem. All right, so in this case, what we do here is, in order to determine the total number of way I can distribute these cookies, I added the 10 symbols. In this case, it's 10. And I want to choose 3 of them. All right, that's the way that I choose the sticks here. Okay. All right. So that being 10 choose 3, we get 120. So 120 way to distribute the cookies, 7 cookies among these 4 kids. Okay. All right, so here in this case, we can think of here we have K2 to generalize our problem, we have k identical objects into n bins. All right, you see here we can think of this as bin 1, bin 2, bin 3, bin 4. Right? And what that translates to, k is going to be identical objects. Those are going to be my stones. Right? And my bins is going to be represented by n-1 sticks. Right? K stones, and for the sticks, n-1 sticks here. Okay, so let's say here for the jelly bean problem, right? So really, let's say for example here, let's say we had 5 different colors here. All right, so let's say there were 5 colors, right? And I wanted to choose, let's say 10 of them, right? So for the jelly beans, so there are 5 different colors, and I want to grab a handful of 10 jelly beans. Okay, so the identical objects here are the jelly beans, right? So in this case, our formulation here, k here excuse me, is going to be 10, right? And then the bins is going to be 5, right? The bins corresponds to the different colors, right? So the way I do that is going to be here. So we have 14, because I'm going to need n-1 sticks, so that gives me 4 plus 10. And then out of that, right, choose 10. Okay. All right. Okay. So then doing that, that means that 14 choose 10, where we get 14 factorial over 10 factorial times 4 factorial. So we get 14 times 13 times 12 times 11 over 4 factorial. Let me do a quick calculation here. Where we get 14 times 13 times 12 times 11 divided by 4 times 2. Then we get 1,001. So 1,000 ways, 1,000 different handfuls of 10 jelly beans over the 5 different colors here. Okay, now here we don't worry about, we'll assume they're all equally likely that you grab them, right? That really is not the question being asked here. It's just that how many different ways that they can happen, right? Some, depending on how many of each jelly bean there are, some are more likely than others, but again, not the question being asked at the moment here. Okay, so now in general, the general formula that we have, so it's our choose number. So up top, we're going to have however many k distinct objects that we have. Sorry, k identical objects. And then the sticks. And then choose those k objects. Okay. So that is our formula for counting these multi-sets.